Here's problem number 27, which they are working really hard to trick you. There's a difficulty with this problem that may be hard to see if you're not looking for it. But on this interval of integration, this function is not defined everywhere. It's defined somewhere in that interval. It's not defined at 0. So really what we have to do is we really need to break this problem into two parts. Limit as x approaches, not x, as b approaches 0 from the negative side of the integral from negative 1 to b of 3 over x squared dx, and the limit as, probably I should write this as a approaches 0 from the positive side for the integral from a to 1 of 3 over x squared dx. Now, what happens now is that either one of these improper integrals diverges, then we say the whole thing diverges and the integral doesn't exist. Let's go ahead and work on one of them. I'm going to choose to work on this one because I prefer to have that limit being on the bottom. All right. So how about the limit as a approaches 0 from the positive side, and I am going to find the antiderivative of 3x to the negative 2 from a to 1. The limit as a approaches 0 from the positive side, let's see, increase the power by 1, multiply by the reciprocal, and there's how we're going to evaluate that. And so that's going to be the limit as a approaches 0 of negative 3 to the 1 to the negative 1 power minus a minus 3 a to the negative 1 power. All right? Let's focus in on this part right here. This part, which is essentially 3 over a. What does 3 over a look like? Well, it looks like the standard hyperbola, and it does so as we get closer and closer to 0. This thing is shooting up. This thing right here is infinite. This limit is unbounded. And because it's unbounded, we say the whole integral does not exist.